In a small farming community, there was a family-owned dairy farm run by the Johnsons. The Johnsons took great pride in their work, but they were facing challenges in managing their herd and milk production efficiently. Realizing the need for improvement, they sought the expertise of a systems analyst named Maya. Maya was known for her systematic approach to problem solving. Maya spent time observing the farm's daily operations. She noticed that the milking process was done manually and was quite time-consuming. Additionally, the cows' feeding schedules seemed to be irregular, affecting their milk production. Maya began by collecting data on the cows' feeding habits, milk production, and the workflow of the farm. After thorough analysis, she proposed a simple yet effective plan. Maya recommended the installation of an automated milking system to streamline the milking process, allowing the cows to be milked more efficiently and reducing the time and labor required. The automated milking system reduced the time spent on milking, allowing the family to focus on other essential farm tasks. The automated system also reduced the physical strain on the family, allowing them to manage the farm more comfortably. She also introduced feeding schedule optimization. For this, she suggested establishing a consistent feeding schedule for the cows, ensuring they received the right nutrition at regular intervals, which could potentially increase milk production. With a consistent feeding schedule and better care, the cows started producing more milk. The changes brought about significant improvements. The Johnsons were delighted with the positive changes. Their dairy farm became more productive, and they had more time to focus on other aspects of their business. This example showcases the power of thoughtful system analysis in solving practical challenges. Hello everyone. Welcome to the lecture series on health management. We discussed that management methods and techniques are broadly classified into 5 categories: statistical techniques, activity analysis, mathematical techniques, financial techniques, and others or miscellaneous techniques. Mathematical techniques include techniques like simulation study or models, systems analysis, linear programming, inventory control methods, precedence and arrow diagramming, and network analysis. In this session, we will discuss the systems analysis. Systems analysis and design is an active field in which analysts repetitively learn new approaches and different techniques for building the system more effectively and efficiently. The primary objective of systems analysis and design is to improve organizational systems. System analysis is a process of studying a system or its parts and solving the problems to improve the system and ensure that all the components of the system work efficiently. System analysis specifies what the system should do. Systems design is the process of planning a new system or replacing an existing system to satisfy specific requirements. Let us first understand what is a system. A system is a group of interdependent components linked together to achieve a specific goal. In a system, the different components are connected with each other and they are interdependent. For example, the human body represents a complete natural system. A system has the 5 basic properties. Number 1, organization. Organization implies structure and order. It is the arrangement of components that helps to achieve predetermined objectives. Number 2, interaction. It is how the components of a system operate with each other. For example, in an organization, the purchasing department must interact with the production department and the payroll with the personnel department. Number 3, interdependence. Interdependence means how the components of a system depend on one another. For proper functioning, the components are coordinated and linked together according to a specified plan. Because the output of one subsystem may be a requirement for other subsystems as input. Number 4, integration. Integration is concerned with how a system's components are connected. It means that the parts of the system work together within the system even if each part performs a unique function. Number 5, central objective. The objective of the system must be central. It may be real or stated. It is not uncommon for an organization to state an objective and operate to achieve another. Elements of a system. There are three major components in every system, namely input, processing and output. Inputs are the information that enters into the system for processing. Output is the outcome of processing. The processor is the element of a system that involves the actual transformation of input into output. Feedback provides control in a dynamic system. The control element guides the system. The environment is the supersystem within which an organization operates. Boundaries are the limits that identify its components, processes, and interrelationships when it interfaces with another system. Types of systems. Physical or abstract systems. Physical systems are tangible, means we can touch and feel them. They may be static or dynamic. For example, in a computer system, desks and chairs are the physical parts which are static. A programmed computer is a dynamic system in which programs, data, and applications can change according to the user's needs. Abstract systems are non-physical or conceptual entities that may be formulas, representations, or models of a real system. These are usually theories, principles and concepts, open or closed systems. An open system must interact with its environment. It receives inputs from and delivers outputs to the outside of the system. For example, an information system must adapt to the changing environmental conditions. A closed system does not interact with its environment. It is isolated from environmental influences. A completely closed system is rare in reality. Adaptive and non-adaptive system. Adaptive system responds to change in the environment in a way to improve their performance and survival. For example, human beings and animals. A non-adaptive system is a system which does not respond to the environment. For example, machines. Permanent or temporary system. Permanent system persists for a long time. For example, business policies. Temporary system is made for a specified time and after that, they are demolished. For example, a DJ system is set up for a program and it is disassembled after the program. Natural and manufactured systems. Natural systems are created by nature. For example, solar system, seasonal system. A manufactured system is a man-made system. For example, rockets, dams, trains. Deterministic or probabilistic system. The deterministic system operates in a predictable manner and the interaction between system components is known with certainty. For example, 2 molecules of hydrogen and 1 molecule of oxygen make water. The probabilistic system shows uncertain behavior. The exact output is not known. For example, weather forecasting and mail delivery. Social, human-machine, machine system. The social system is made up of people. For example, social clubs and societies. In a human-machine system, both humans and machines are involved to perform a particular task. For example, computer programming. Machine system is where human interference is neglected. All the tasks are performed by the machine. For example, an autonomous robot. Man-made information systems. It is an interconnected set of information resources to manage data for a particular organization, under direct management control. This system includes hardware, software, communication, data, and applications for producing information according to the needs of an organization. Man-made information systems are divided into 3 types. Formal information system. It is based on the flow of information in the form of memos, instructions, etc., from top level to lower levels of management. Informal information system. This is an employee-based system which solves the day-to-day work-related problems. Computer-based system. This system is directly dependent on the computer for managing business applications. For example, automatic library system, railway reservation system, banking system, etc. System development life cycle. There are 5 steps in the system development life cycle. Number 1, planning. In this step, we need to define the problem and scope of the existing system and determine its objectives. During this phase, threats, constraints, integration and security of the system are also considered. Number 2, analysis. In this step, all the information related to the system is gathered, analyzed, and validated. Number 3, design. Based on the user requirements and the detailed analysis of the existing system, the new system must be designed. Number 4, implementation. Implementation is the stage of a project during which theory is turned into practice. And, number 5, maintenance. Maintenance is necessary to eliminate errors in the system during its working life and to tune the system to any variations in its working environments.